Dear participants, today is the 14th day of this international workshop on digital image processing. And today we have a resource person, Dr. B. Mahalingam sir. He is the person to whom introduction is not required because he is a man of technology. Presently, he is working as an assistant professor in Central University, Karnataka. And when we talk about technology, because I know him very well since 2006 when we met in Bangalore, and since long back he is working in the area of geospatial technology. At present, various research articles, books, book chapters, research projects, etc., are at the credit of Dr. Mahalingam sir. And more or I would like to say that he has conducted more than 421 days training programs in the area of remote sensing and GIS. I'm not going to introduce much more because his demonstrations will introduce himself to you. With this brief introduction, I request Dr. Mahalingam sir kindly proceed ahead.
Good evening, Sardar sir, and
Very
good
good
evening to
evening.
everybody. And Sardar sir has given me a task to teach what is supervised classification, and from the basic, like he asked me to demonstrate most of this session with some explanation about what is supervised classification, what is the uh, digital image. So I would like to interact in the middle of the session, like it's not going to be a one-way delivery. So I would like to interact with me when you have the doubt, or you can raise your hand when you have the doubt, or we could not, when you could not understand what I'm saying here, you can raise your hand, and Sardar sir may allow you to interact with me, right? Right. So in today's this session, I am going to explain about what is supervised classification and what are the data we may need, or how we can perform with the tools which was developed for this purpose. In today's class or in this session, I am going to discuss about image classification, especially for supervised classification. Tomorrow, Sardar may take the classes for unsupervised classification. So when we talk about any kind of classification using remote sensing, which can be a supervised or unsupervised or this object-based image classification, we need a satellite imagery for the place where you are interested. Then this satellite imagery will be classified based on the pixel values which are similar with one another, and this classification will be converted into vector data, or even with the raster data we will identify the areas, and these areas will be calculated based on the square kilometer or any other unit, and we may also find out the percentage of specified classes covered in the study area. Then finally we will come up with the kind of diagrams or the graphs which will illustrate the land use land cover of the area, right? So the primary thing is we should have the objective to identify the land use land cover of any area. To do that, you may get the satellite imagery, and there are lots of satellite imageries are available for free of cost, or like there are satellite imagery which we have to purchase it. Once you have purchased it and we have to use some kind of tools which is developed for it, then we perform the classification. Then we will identify the different kind of classes which we have asked for. Then the area we will find out, and we will prepare the table, and we will represent it as I have shown this, right? So for this we use different kind of classification algorithms, which is called as a supervised or unsupervised or object based. So in this class we are going for supervised classification. So when you have decided you want to identify the land use land cover of any area, the first thing what we do is we will purchase the satellite imagery, like we pay some amount of money to the organization which they are selling the satellite imageries, or there are some satellite imageries which is can be downloaded for free of cost. Like for example, you may have come across in this training program Bhuvan portal and Glovis and USGS portal, from where you can download the different kind of satellite imageries, right? So when you want to get the satellite imagery, there are some certain things which you have to keep in our mind, such as the date the image has been taken and month the image has been taken, or the year which the image has been taken. So this is very important when you download the data or purchase the data for any analysis. The date, month, year, in sometimes the time the image was captured is very much important to identify. For example, when you want to go for this land surface temperature analysis, the time of the image taken also very important. So these things we will consider, right? And we also consider the spatial resolution, spectral resolution, radiometric resolution, and temporal resolution of the satellite imagery, what we are going to download or purchase it. For example, when you want to go for the large scale map in which you want to measure the building's area, in that case we should go for the high spatial resolution satellite imageries. Whereas when you want to find out the only the area covered by the forest or area covered by the agricultural land, which is a large scale map, in that case we can also go for this Landsat or list 3 satellite imageries. So the spectral indicates the number of channels or number of bands in the satellite imagery. So higher the spectral bands will give the more detailed information of the feature on the Earth's surface, whereas less spectral will provide us less information. So based on the information what you want to extract from the satellite imagery, you can decide how many spectral bands is necessary for it. So the radiometric resolution decides the number of or the bit in which the satellite imagery is stored. So for example, if the satellite images are stored with the 8 bits radiometric resolution, then the pixel value starts from 0 to 255, in which like you get the certain level of information. When you want to go for a more information on this radiometric, then we can go for the satellite imageries which is stored in the higher bits, like 16 bits or even more than that, right? Temporal resolution, and this is very important when you deal with the different dates or different time period data to identify how this land use land cover or the phenomena on the land surface has been changed over the time period, right? So if you are satisfied with the date, month, year of the image what you want to purchase or you want to download with this spatial, spectral, radiometric and temporal resolution, then we have to say whether we have the tools to handle this software, handle these data, because you may have the software which is efficient to work with the vector based data, but these satellite imageries need the software which has the specific tools which can handle the raster based data, the pixel analysis and other special tools for the supervised and supervised or object based classification, right? So if you are capable of handling the data with the software, then we can purchase or we can download. Then when we download or purchase the data, so generally the data covers by the scenes, like it may be rectangle or it can be a square, the area which present in the satellite imageries. So generally in the steady area, what you may have may be in the polygon, which is does not have the proper shape, which can be administrative boundary. In that case, the steady area of yours should be clipped or should be extracted using the specific tools, right? So once you have purchased or download the imagery, and once you have satisfied with the date, month, year and spectral, spatial, radiometric, temporal resolution, and once you have confirmed you have the tools and software to handle this data, then you can delineate your steady area. Then you have to develop the classification sim, which can be called as also legend, because the satellite imagery is made up of pixels, and this pixel, wherever it is having the similar values, we say these are all belongs to same features on the Earth surface, right? So for example, like these pixels has to be classified into different classes, like 4 or 5 classes, and you should decide which classes it should be, like water bodies, agricultural land, or build-up land, or grass areas, right? So this you have to develop. This developing the legend should be based on the user, those who are going to use your classified image or your result. So based on their requirement or for what purpose the land use land cover is going to be used. So based on that requirement, we will classify the classes or we will prepare the legend of it, right? Then we will prepare the imagery for the classification, and not only that, we will also collect the ancillary data which may support for our land use land cover result. For example, you may do the work for some specific city or the taluk. For that, there may be some information which is already available in this analog format, or the government may have information about the land use land cover, which will support you when you do this land use land cover classification is supervised or unsupervised. That information will help you a lot when you do the work with the data. Like once you have the data and once you have the software and once you have decided the legend or the classification classes, and it is the next step in the supervised classification, which algorithm you are going to use. So there are lots of algorithm was developed over the time period, and this is not a limited number. So still it will be developed over the year, right? So there are parallel piped classification algorithm is there, minimum distance to mean classification is there, and Monopolis distance classification is there, binary encoding classification, principal component classification, supervised vector machine, random trees, k nearest neighbor, and maximum livelihood classifications are there. So even though there are like 2, 4, 6, 8, 9 classification I have mentioned here, so I cannot say that this classification system algorithm is much better than another one. So we cannot straight away say that if you use this minimum distance to means classification, you will get better accuracy. So there is no kind of thumb rule. This will provide you higher accuracy. So the thing is that like it varies from one place to another place based on the pixel arrangement or the cluster what you have. So sometimes one classification algorithm will provide you the higher accuracy than another algorithm. So the better way is identify how much accuracy is your classified result is based on this accuracy assessment. So we do use this algorithm to group or cluster the pixels which are having the similar values in the satellite imagery. Once we have classified it, then we will perform this accuracy assessment to make sure that our classification is correct. So if you get the less accuracy, for example, if you get the accuracy is 60% or 50%, then we have to increase the accuracy by remodifying the supporting classes what we have given, right? So that we will see one by one, right? So what is the mode of classification is, the goal of image classification is to divide up all the pixels in a digital image into various categories of land use land cover, right? So you have the satellite imagery. That satellite imagery has to be divided into different groups based on the pixel values, and it will be categorized. So there are two methods, as I said, which is used for classifying these pixel values, which is called as a supervised classification, and another one is unsupervised classification. Now the new method is constructed called as a object-based classification system, right? So in supervised classification, the analyst or the person who does this work will provide the samples to the system, and based on this sample, the similar values in the satellite imagery will be classified as a same group. Right. The analyst or the person who does this classification choose representative samples for each land cover and land use classes when conducting supervised classification. Then these samples will be provided into the tool. Then the software applies this training location to the whole image. So it's a kind of assumption that the pixels in a satellite imageries, or for the water pixels in the satellite imagery, may have the specific pixel values. So the same pixel value is applied for all the water body pixels in the satellite imageries. So that is a concept used in the classifications. So the training set spectral signature is used for supervised classification. Like we select some sample areas and that's called as a spectral signature and we use it. And this supervised classification is done when the user or this analyst knows the area well. So if he does not know what is the feature on the satellite imagery, then he cannot pick up the sample and he cannot provide to the tool to analysis. So the analyst should know what feature it is. When he knows this is a water body, this is the vegetation, this is the barren land, or it is a forest area, or it is agricultural land, and from there he will pick up some samples and it will be provided to the tool for the analysis, right? Uh, and when this user or the analyst, when he perform this supervised classification, there itself they will specify what classes they need and how many classes they need it. So here I'm going to demonstrate with the data which I have here, which is downloaded from Sentinel Hub, and another one is from Bhuvan portal. Then I have my own data which has captured using the drone, right? So when you download the data from a portal, like kind of online website, so they provide the data in zip file format, in which metadata also included. In some portal will not give the metadata with the zip file. It has to be taken separately. Like for example, in Bhuvan portal, they do not provide the metadata with the data. It is provided in a different pop-up window that we have to copy and paste it in any kind of file which we are familiar with. So I have downloaded the metadata of Bhuvan and I have stored this in the notepad. So where I can see the details of these imageries, right? So when you download the satellite imageries, it is very much important to have the metadata of this file, because this satellite imagery what you download or what you purchase, so this when you take these bands alone into the software or into any other places, so this does not have when it was captured or what spatial resolution it was captured or how many bands were there over the time after you have manipulated it. So it is always better to have the data with metadata for a better understanding of the data like over the time, right? So I'm going to use R Pro, which we have in our department. In this, I'm going to demonstrate you what is band and how to perform this layer stack or the image composite and how to perform the supervised classification. So this, what I'm going to do in this software will be almost similar with any other software. The concepts are same. Only the graphical user interface will change from one software to another software, but the concept behind this classification will be same. The statistical method what they have used here will be same in other software also. Okay. So here I have Sentinel data, and here I have list 3 data. Here I have drone data. So first I will explain you this list 3 and Sentinel data. So I extract it. Right. So this is list 3. When I open the list 3, like I can see the file which is having the kind of code which indicates the data and is that the file name what they have given for this specific place as well as the day it was captured. When I open it here, I can see like there are some files which is readme and policy of the data which the producer has been developed, and as well as we can see there are 4 bands are there, which is band number 2, band number 3, band number 4, and band number 5. So this band indicates the information which is collected in a specific wavelength. So if I want to say exactly in which wavelength, here I have this information. Right. Right. See here. This is the information about list 3, the data which I have right now in my hand. And here you can see the number of bands in list 3 is 4 band, and here we have 1, 2, 3, 4 bands, and here we have the spectrum or the region in which this data was collected or the information was stored, right? So band 2 is covered between 0.5 to 0.59 micrometer, and band 3 is captured in 0.6 to 0.68, which is the region of red micrometer. Then band 4 is collected in 0.77 to 0.86 near infrared region, and band 5 is collected in 1.55 to 1.70 micrometer, which is called the region of short wave infrared. So all these 4 bands are here in our folder, which I have downloaded. See, if I open these 4 files, we will see how it works. I open this. So I have band 2, band 3, band 4, band 5. It may take some time because when the image is opened the first time in the software, any software, it will ask for pyramid layer creation or statistical calculation. So which will allow us to render the image very fastly, which means like when you zoom or zoom out or when you move the images, this rendering will happen very fast. That's why we do, or the software do calculate the statistics before it opens in any software, right? See here I have 4 bands. This is the first band, or if I want to say exactly, I will see this. This is the band 5, this is the band 4, this is the band 3, this is the band 2, right? So if I make it visible one by one, you can see all these bands are representing the same place, right? So when we are going to collect the information of a particular place, so why we want to capture in different bands? Even a single band may provide the information of the place, right? So why these people are collecting more than one band, right? So the thing is that when these bands are captured in different wavelength, like it is in 0.5 to 0.59, in the green region 0.62 to 0.68, in red region. So the thing is that when these particles are the features on the Earth's surface, reflects the energy after receiving from sun or any other sources, right, like artificial source, and these features reflect in different manner, right? So for example, here we have a feature, even I do not know exactly what it is, I could not find out, but it's some feature which has given a reflection or higher reflection than any other pixels. And here we have a kind of feature which is in the black color, and it has kind of shape which represents the water body, right? So we will see how these values are stored in different bands. I click on here. See, in band 5, the pixel value of this particular area is 260, right? So if I click on this, like here, or else I will zoom a particular place, you can understand. Right, now I will click on here. See, in band 5, the pixel value is 148, whereas in band 4, the same pixel is area pixel is having 227, and in the band 3 it is 77, in band 2 it is 102, right? So there is a feature in this particular area, but the reflected energy from this particular feature is differ from one wavelength to another wavelength, right? So this wavelength differ from one specific place to another specific place will make us to understand what kind of feature it is present here, right? So even right, like we will go with any vegetation. So here in band 5, pixel value is 111. In band 4, pixel value is 200. In band 3, pixel value is 63. In band 2, pixel value is 92. So it is a single feature which has reflected to the sensor in different amount of reflection in different wavelength, right? So there are different sensors are fixed in the satellites, and these different sensors are capture the information in different wavelength, and based on the energy of reflection, then the number is coded here, right? Higher the reflection, higher the number will be stored. Lesser the reflection, lesser the number will be stored. So here we have this, like here we have white color or brighter value. When I click on it, here you can see this is 292, 250, 143, 145. Right. So whereas if I go to any dark places, if I click on it, here you can see the value is like within 100, even within 70. Whereas in other pixel we have seen more than 200, but here it is less than 70. In band 5 it is 33, in band 4 it is 67, in band 3 it is 61, in band 2 it is 89, right? So which means that the features on the Earth's surface having the different kind of reflected amount of reflection in different wavelength, right? Right. So when we have more number of bands, then we may have how these feature on the Earth's surface reflects energy in different wavelength can be stored as a bands here, and using this band information we can identify what feature it is in so precisely. Sardar, shall I move on, or any question is there? Right. Right. So here I have 4 bands, and I have the 4 different combination of pixel values. Right. So here 2, 3, 4, 5, 4 bands we have. So there is a kind of tool which will allow us all these 4 bands to stack together. So the term for this tool differs from one software to another software. I think in Iridas it is called as a layer stack. So in RGS and RPro it is called as a image composite. I am going to perform image composite, which is here in imagery process. I do composite. So when I composite, or when I stack all these 4 images and one on another, I get multi-spectral image. So here it is the band 5, which is a single spectral image, band 4, which is a single spectral image. These single spectrals are stored as a single files. Whereas when I composite all these together, then I get multispectral image. So the multispectral image is the image which is stored as a single file with a more than one band with that, right? So when you change these band combination in a multispectral image, some of the feature can be easily identified with some specific band combination. So for example, what we see here is which is called as a false color combination. So why it is called as a false color combination means because the information what we see here is not we usually see by our eyes. So as it is differs, as it is not the true information what we see by our eye, it is called as a false color combination. So there is a imagery which is called as a true color combination, which shows the satellite imagery exactly the same way how we see the land surface, right? So this can be achieved by interchanging these bands. Right. So I go with red should be in 4, because here if you see the 4th band is near infrared band, or the information captured in the region of near infrared, and 3rd band is red band, and the 2nd band is green band. So there is a kind of term called false color combination, or we can say it is a standard false color combination in which the near infrared band is shown with the red spectrum, or red stretch, right? And this red is shown with green stretch and blue is shown with green stretch, right? So when we have this combination, then we will get the default or the standard false color combination. So here I kept it as a temporary file, that's why it doesn't come. So I will remove this. I will make the this layer composite once again. I will save it in a file. I save it as a permanent file after layer stack date or composite date. Right. So now I have the permanent image. Band 4, band 3, band 2. Right. So when you change it, you can see like the appearance of image changes. The appearance of information get changes, and this we have the information about it. See here, the data what I have showed here in R Pro is list 3, but here I have the information of Sentinel-2 bands, right? So what I do, or here itself we will see here Sentinel-2. See here. So in Sentinel-2 there are 12 totally 13 spectral bands are captured in different wavelength and different spatial resolution. So when you use this data, if you use band 4, band 3, band 2, so it will give you the natural color, right? So it will provide you the natural color or true color combination, how you see it. But if you see change it into band 8, band 4, band 3, whereas here we have only 4 bands, but in Sentinel you have more number of bands, which is almost 13. So when you make the combination, you can find out this color infrared band combination, right? So here, like here, when we change it short wave infrared with the band 12, band 8A, band 4, right? So these are all different combination to visualize the image. And if you want to find out the agriculture features, or if you want to see these agriculture features very clearly on your satellite imageries, and we have to use band 11 in red, band 8 in green, and band 2 in blue. So you will get the images looks like this, in which you can identify the agriculture areas very clearly. So if you want to find out the features of geology, then we may use band 12 in red channel and band 11 in green and band 2 in blue. So these geological features on the imagery will be clearly visible, then you can easily identify it. So for bathymetric, it is band 4 in red and band 3 in green and band 1 is blue. So bathymetric information, we can easily identify it. Right. Other than that, we have the indexes using which like we can identify some specific features very clearly, like NDVI or NDWI, normalized differentiate water index, or normalized differentiate build-up index, or soil adjusted vegetation index. So these indexes are also there, using which you can identify the information clearly. Sir, shall I move on? Right. So I remove all these things because the file size is large. So I'm little afraid, like if I get stuck in the middle, like it may waste our time. Small area of drone image. I open it. Do you see my screen? Okay, okay. So this is the imagery like we have captured using the drone and when we have captured, we have used only 3 bands, that is red, green, and blue bands. So this information, red band information is collected in red region, green is green region, blue is blue region, and finally we have done this layer composite to make this individual red, green, blue images as a multi-spectral image we have here. And this is a high resolution imagery, and we can identify the features very clearly here, right? So as I said, there are different classification systems are there. So when we have these high resolution imageries, you can go for this on-screen digitization. So on-screen digitization also will give you the higher accurate resolution, using which you may create the vector data, then you may create the polygon for these species. So generally this on-screen digitization will not provide with the high accuracy result with the coarse resolution. So we may go for digital image processing, and we also can perform the digital image processing with this satellite, this drone or satellite imageries. But the thing is that when you want to digitize a polygon for all this building, like it may take longer time, right? And there are some possibles you may make the mistake when you create the polygons in the on-screen digitizations, right? But if you feel that like you want to reduce the timing of classification, or if you want to get the result very fast, then this digital image processing will help you. So we cannot say this digital image processing may give you the higher accuracy than on-screen digitization, but the thing is that it will reduce your time of getting the result. So here I have 3 bands, like I can change the band combination like how I have done with the satellite imageries. So I can see some specific information are clearly visible when I change this band combination as a true color combination, right? Right. So as I said, in supervised classification, the analyst or the person who does this task will select the sample from the satellite imageries, then it will be provided as an input for the classification, and based on the input, the similar pixels in the satellite imagery will be classified as a same class and the result will be provided, right? That I will do it now, right? First I have to collect the samples from this satellite imagery to provide to the tool, saying that these are all belongs to this group, right? So to do that, I have to make a training samples or the training site, right? So when I go to the training site, and here is a default legends or the category which was predefined with the tools, and which starts with water, development, barren, forest, and forest is having the subclasses in it, and shrubland, and we have other classes also. But the thing is that these classes may not match with all the places, right? So these classes, if I see here in this case, I cannot say the forest or I cannot say the wetlands here, because it's a smaller area which is mostly covered by this agriculture land and fallow land and built up land. So in this case, this thing will not, legend will not help me. So what I do, I don't want these predefined classification schema. I want to create my new one. So can anyone tell me what, see, if I use the land use land cover classification for this image, what are the possible classes we can make it? See, here we have building, here we have, guys, can anybody, what are the classes we can make it in this satellite imageries or drone image?
Sir, settlement, cultivated land, vegetation.
Okay, we can go for settlements, or instead of going for settlement, we will go with the term called build up. Okay, we can go with build up, and we can go with vegetation is there, then fallow land is there, right? So I will take 3 classes now. One, I will say that one class is build up, another class is vegetation, which consists of these trees and the crops here. Then the third class is a fallow land here, right? So I say my classification is contained build up. So here what we are providing, it is a name of the class, right? But the software or the tool, when it works, it does not understand the text what we have given. It works based on the values what we have provided. So I provide the value 1 for build up, right? And when I create this class, I say build up should result in my output with the red color. I have created one class, then again I create one more in the name of vegetation, and I provide the value 2 which belongs to vegetation. Then I provide the color green here, then I click on OK. Then third, I add fallow land, for which the value of 3 is assigned by me. Then the fallow land, I provide the symbology or the color of yellow, right? So here I have prepared my schema or the legend, right? So in which I am going to classify 3 classes: builder, vegetation, and fallow. So now I'm going to pick up the sample pixels. So I click on build up. Then here I have the different selection tool, and I can take this polygon. I will make it tag. Right. Do you see here? I have taken one sample, and the pixel which is inside of this region is taken for sample. And if you see, even in the building, there are different color we can see here, which means like these are all given different reflected energy there. So that I select this building, and this building, like the maximum possible samples would provide higher accuracy. So instead of going for this polygon, I select the circle. So to make a circle on the buildings, so I can do it fastly. And we should be careful that when you select the sample for a particular class, and this area should not fall on any other class. For example, when you select for the building, if you select like this, and there are some pixels which belongs to vegetation also comes in it. So if it is the pixels are overlap from other classes, our result will be wrong, or we will not get the higher accuracy result. So I delete this which I have created wrongly here for your understanding. I remove it, I feel some of the pixels of vegetation also overlapped here. Which one I have selected? Okay, I feel I have taken enough um, number of samples. Then I merge all these sample, because all these are representing same feature class. So I merge it, then which is named as build up, right? So these many samples I have given as a sample for build up. Then I will move on to collect the samples for vegetation. So here we have kind of crop which they have cultivated. They are cultivating. Here we have the tree. Here we have the tree. Some places of vegetation here. Here we have vegetation, trees, tree, tree, vegetation. I have collected these many samples for vegetation. Then I merge all this thing into a single sample here. Then I selected fallow, so I may select some areas which actually the pixel belongs to fallow on the real world. See, actually, these pixels, which is kind of, I think it's a kind of pipeline which is placed in the middle of this fallow land. But we are considering this as a fallow land now because we are selecting the pixel of this also as a fallow land, and it is not right. We do one thing: we will avoid this pixel and we will collect the samples by leaving it. We will see how the result comes because I'm leaving there is some structure which provides the higher brightness. I think there are some particles they have placed on the fallow land. So I have taken 4 samples, or like still I will take some more because here the pixel values are different from the sample what we have taken. And here there is kind of some vegetation is there. I don't want to add these pixels into the sample of fallow, so I leave it. I take these pixels. Right. So now we have this many fallow sample classes, which consists of hundreds of pixels here as our sample. Then I merge it. Right. So I have decided that like there are 3 possible categories I can classify, but even we can go more. Like here we have the trees. Trees can be put as a single class here, and this vegetation or the crops can be put on the another class, right? So, but we have considered these 2 as one class as a vegetation, right? So once we have given the samples or selected the samples, or which also called as a training sites, then it should be saved. I save this, which is called as a training sample scheme. I save this in the name of scheme, and it should be saved on my folder. I save this in the class in the name of schema here. I saved it. Then this is the legend or the category which we have classified, and these are all the samples. So I have 18 samples in builder. I have 13 samples in vegetation. I have 7 samples in fallow. So these samples I'm saving it in the same folder here. Here I may have one more file. In the name of samples .shp. That is a file format in which it gets stored. Right. So we have stored the classification legend as well as the number of samples we have taken for each classes. Am I clear?
Yes, sir. Yes, sir.
So is there any clarification you need, any explanation you need?
Sir, actually, Dr. Atul Jete
Hmm.
commented that which software
Hmm.
is being used, and
Um,
one has responded that it is Arc Pro. But if you want to focus more light on that, please.
no, the thing is that like the thing what I'm doing now is possible in other software also. Even in the freely available QGIS software, we can perform it. So the concept is same. Whether it is QGIS or whether it is ArcGIS desktop or it is ArcPro or it is IRDAS or it is Idrisi, or if you use the NV software, the concept behind this classification is same, right? So you will have the satellite imagery and you have to pick up the sample which you are going to provide as um, samples for the analysis, and the tool will take these pixel values as a sample, and the similar values in the entire image will be classified as a same class as your input. For example, here I have given the build up, and build up is covered, the sample is covered by the area of building, and these pixels which is inside of this sample area will be compared with entire image, and the similar pixels in the image will be categorized as the build up. And here in the vegetation, if you see like the pixel values here will be taken as a sample, and the similar pixels in the satellite imagery will be classified as a vegetation. But the concept behind it is same. Like when you use this it differs. Like I can say example of if you use Android mobile phone or iOS mobile phone, only this graphical user interface in it will be changed, but the function what happens inside will be same. Am I clear, Sardar?
Yes, sir. One more question I would like to ask on
Yeah,
behalf of my PhD student.
yeah,
Suppose we, because he is working on a renewable energy, that is solar energy potential of Badlapur city,
yes, yes.
and if we use this technique
Mm.
to get the building footprints.
Yes,
Either that already you told about object based classification,
yes,
that
yes,
will useful, or else because either it is considering the road as a same layer, because each building have different spec may have different spectral reflectance based on the color at the rooftop. So is it possible to do the same task in arc?
yes,
Did you
yes. We can do.
Yes, did you get my question?
See, you want to extract the building
Building tops
footprints.
only building tops, because I
Yes,
have
yes.
assigned the work to digitize him
Mm,
from
mm.
Google, and
Ah,
he is
yes.
doing, yeah, he is doing that task. But with the view to save the time, is it possible to extract 100% accurate building tops using this classification technique?
Okay. So the question is, if you use this image classification technique, whether it is supervised or unsupervised or object based, will I get 100% or not? That's the question, right?
Yes, 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 yes.
We will see after this classification. We will see how much accuracy we get.
Okay, thank you, sir. Please proceed ahead.
Yes. So I have the satellite imagery, like drone image, which is also a kind of satellite imagery, and I have given the samples for three classes. It is not limited, like based on our requirement, based on the satellite imageries information what we have, the classes can vary, right? It also varies from one place to another places, right? So once I have selected the samples, now I'm going to move for classification. Right. So here, in this software, and these are all the tools which is already developed and available here. So we have supervised and unsupervised. Unsupervised means without the influence of analyzed, tool itself will group the similar pixels, and it will classify into different classes based on only the classes we will say. So if you say 5 classes or 6 classes or 7 classes or 3 classes, then based on the pixel values and its clustering, the entire image will be classified into the defined group. Whereas supervised classification, the analyst will provide the samples, which is the training site, or now we have saved this as a samples. So these samples will be provided as an input to classify the entire image. Right. So here we have the classification method is supervised, and here we have the algorithm, or sorry, classification type, whether you are going to do with the pixel based or object based. Here I'm going to do with the pixel based, and the classification schema, which means that the legend what we have prepared, right, in build up, vegetation, and fallow land we have done. No, so that file which we have stored already should be provided here. I open it here. This is in folder class schema. I have saved in the name of schema, in which that number of classes are stored. And here we have 3 classes here, which is we have stored in this schema, and the training samples, in which like we have selected 80 samples for build up and the other number of samples for vegetation and fallow run. So that information should be provided here. I will select it here. It is in my folder in the name of sample. This is the one, right? Then I'm going for next one. So as here I have given the schema or the legend or the category what I have already have developed and saved, and here I have inputted the samples. The samples in which I had a number of polygons for agriculture, not vegetation, and builder and fallow land. So that file I'm opening here. Then I go to next. Here we can see like this schema or the legend what I have already developed, as well as the number of polygons or the samples which I have taken for each category. Am I audible?
Yes, yes, yes.
Oh. Then I click on next, and here we have the algorithm, which classifier or which algorithm you want to use it. whether you want to use k nearest neighbor or whether you want to use support vector machine and random tree or maximum livelihood. So as I said earlier, like we cannot predict now this the algorithm may provide you higher accuracy result than one and another. So the better way is whatever the algorithm you use, get the result and you find out the accuracy using this error matrix or kappa coefficient. So which we may discuss in coming days, right? So now I am going to use this maximum livelihood classification method, which is one of the popular method algorithm used for supervised classification. Then I run it. So it may take few seconds to produce the result, right? So it has produced the result based on the sample what we have given, and it's a preview one. I save it to make it permanent. I save this as classified maximum livelihood 17. I don't want like, right, the coordinate system, everything is there and it is stored in 8-bit. Okay, then I export it. Okay, here we have our exported result, right? Here I have my drone image, here I have the result, and we will see how accurately it is classified. I do sweep it and we will see. Right, see here we have the car, right? This car is classified as which class? Can anyone tell me which class the car is classified?
Vegetation.
The car.
Vegetation.
We have given green for vegetation, and this car is classified as vegetation. Okay. Yes. And here we have one more white car which is classified as build-up.
Built up, yeah.
Right. Because these tools are predefined function based on the statistic. It does not know the real feature how we human can identify it, right? So these are predefined. If there are similar kind of reflected pixels are there, then you make it as this group, right? But we human can differentiate between the features very easily. So we can identify there is not a vegetation, it is a car, right? So here, which is a fallow land, like when you see here, you can see this entire thing is a fallow land. But between this fallow land, you can see your red pixels or result with the red patches, which indicates the build-up. Which means that, so we cannot say that algorithm does not work properly, but the thing is that there are some pixels which have the pixel value of the buildings. See here you can see. See here we have a pixel which is having the red color which indicates the build-up, and if I swipe it, you can see there are some pixels which is the bright values or the higher values. And if you see our buildings, here we have the buildings here, and you can see the similar pixels of buildings is falling in the middle of fallow land, which means there are some this electrical posts are there. So this electrical post has provided the pixel value as the building. That is really correct. But in our classification, we cannot keep these single pixels or this few pixels in the middle of fallow land, and it may not make sense to us, right? So in that case, like we can recode this pixel. This is the result, and we know that it was not predicted correctly. So there are some mistakes are there by seeing or comparing our base map or the ancillary data. As I said, like when you do supervised classification or unsupervised classification, we also collect the ancillary data which provides the information about our study area. So you may come to know that using ancillary data, or when you compare with these things, and these are all not a build up in the middle of fallow land. It's also part of the fallow land because of this unsimilarity of the pixel between the fallow land has created these settlement buildings here, right? So in that case, what we can do, there are some tools which will allow us to convert this class from build up to fallow land. So that I will do now. So which is here, it is called as a pixel editor, but in other software, especially in Erodas, it is called as a recode. Right. So here I have it. So the region which I have to recode or reclassify should be selected. Here I have the option for selection. Like I take a polygon. So I say the pixels within this region all belongs to fallow land. So here I say current land use in this, it's a build up. I want to convert this into fallow land, and here we have the operation. Like each will works differently when you want to recode it or reclassify it. So I go with the expand. Here we have the option for it, expand, and I want to go with how many pixels or how many cells you want. I go with 10, and this should be converted as a fallow. Then I say apply. Have you seen? So the pixels which was misclassified as a build-up and which was recoded by us as a fallow land. So in the same way, like we can do for the entire image. Like I can go for one more here. Right. See, this is the buildings, but it is misclassified as a fallow land. So I select here this area, and it should be fallow land. Here also not necessary because we have the thing here. Then I say it should be build up. Right? Did you get what I'm trying to say?
Yes, sir.
Right. So the reason for the more number of misclassified pixel is due to the less number chances of less number of samples what we have taken, or chances of less classes what we have taken. If you have increased the number of classes like buildings, then roads. So here we have, I think it's a road. Yes, see here, if you have given the different class for roads, and if you have created the different class for agriculture field and trees, and this error may be reduced, as well as increasing number of samples will reduce the error what we get here. And once you have done it, like once you have corrected errors, then this can be converted into vector data, or else we can calculate the area of it. So now I will convert this into the vector data. So we imagine that I have corrected all the errors in it. So here the raster has been converted into vector, and in attribute table we have all the classes here. Then I dissolve it, and based on I dissolve it. here I have the vector data of land use land cover what I have classified now, and here I have a table which shows the area covered by each class. Like I can make one more column here, name of area, right? Right. I will find out the area covered by each one of it. Okay, what is the problem here? Okay. The thing is that like it's a so very less area. I calculate with hectare because I'm calculating with square kilometer. It's a small area, that's why we do not get answer. I go with hectares. Right. So here we have values in hectare. Then we can prepare like we can make it the symbology also. Build up should be red color. Fallow I need in yellow, and vegetation should be in green, right? Then like if you feel you want to make a graph and we have the area in the attribute table, and we can also make a graphs. So what I have done here means like I want to classify the land use land cover of the drone image using the supervised classification. So I have picked some samples which is called as a training site for 3 classes, as I want to make this classify this area into 3 groups, which is the build up, fallow and vegetation. Then using that sample pixels what I have collected has given as a input data for this maximum maximum likelihood classifier. Then this maximum likelihood classifier has taken my sample and it has classified the pixels and made the similar pixel values as a single group into 3 categories. Then this data has been converted into the vector data. There I have identified the area covered by each classes. Then I have prepared the bar diagram, or you can bring this to any other statistical software or even in Excel to make the another diagrams. Sardar?
Yes, sir.
Now I am waiting for your questions. If you ask me several questions and you may get more information from me.
Yes, definitely. Initially, we will ask for the participant, and some questions have been posted in the chat box. I request you kindly go through it.
Is it so?
So this is Anirudh. I have a question.
Uh,
Sir, is the selection of the classifier a very important step? Because now since you have used maximum likelihood
mm, mm,
classifier,
mm.
if I use something else, would my classification differ a lot?
Yes, yes, not lot, not see. Now we have used the maximum lively uh, classifier. Like if you use any other classification, your result will change, but it not much. It may vary like point like within 5% of changes would be there. But whatever the classification you use, but finally you end up with some errors in it, like what we have here. Uh, all these classification, existing classification will not classify your image 100 percentage. That's why we have to prove our classification with this error matrix. So for which we may
Right, sir.
give the, yeah,
The kappa and
yes. So none of this existing, because we cannot say um, there is a mistake with the classification system. See here, which is happen in real. Here, this is a satellite imagery where the pixels are assigned with the reflected energy. So in this case, if you see here, this is a car, right? Red color car, and which has provided same pixel value of what vegetation has provided to the sensor. So that's
right,
why
sir.
this, as these pixels are similar to the vegetation, it has grouped with the vegetation. But these kind of errors we have to eliminate by recoding it.
Right, sir.
So if
Okay.
you use any classification method, but finally you will end up with this car location is the vegetation only.
So you suggest that we recode wherever possible and
We should recode it. We have to
okay.
recode it. All these errors should be eliminated,
Hmm.
because in land use land cover, these areas will be considered as a built-up area,
Right,
right?
right, sir.
So
Right.
because it's a built-up area, then we have to recode it into the build-up.
Okay.
Even if I want to do this perfectly, like I may need at least 2 to 3 hours to correct all the errors, and I will take more
Right.
number of samples and do process again.
Got
And
it, sir.
it is not limited, like you have to go with the same classification what I have here, the schema. See here, now I can add some more classes here. I can add the classes, or else I can increase the number of built up samples here. Then I will run it again to get the better accuracy. And even after adding like 20 more built up polygons, if I end up with some errors, then still I will increase it.
Good evening, sir. I have few questions about the color combinations.
Yes,
Uh,
yes.
why you use the false color combination?
Right.
Because our eyes are habited to see vegetations as green,
Yes,
and the road is black like this, water is blue. But we are changing this. Why we are
yes, yes,
using the
yes,
false
yes.
color combination?
Okay, now I will open the Sentinel images. Mm, but it takes some time, or else I will open with the 10 meter spatial resolution. This much. Okay, here we have the spectral band, which is stored in the separate band. I will make it as composite or layer stacked image. I will save it here.
Sir, is it from Maharashtra?
Might be, sir, because when I have
Yeah,
downloaded yesterday, the Ratnagiri I have searched.
we are searching for this data.
Because I want to show you your location,
Yeah.
but I felt that like when we use the larger data, like it may take longer time, as well as like in online classes, if the software gets stuck, and then it won't be good. That's why I have taken a small area of drone which I had. I do one thing, even this takes longer time, it will not be, I do one thing, I clip the area. Okay. Now I export only the clipping geometry to current display state. Right. It may export easily. Wait, because here when I have done it band 8, I keep the band 2 first. Band 3, band 4 and band 8. I will do composite. Now I export it. Okay. Right. Do you see my screen now?
Yes, sir.
Yes, sir.
So here what I have done, I have composite 4 images as a single image, or 4 spectral bands into a single multispectral band. Right. Band. Right. See, what I have done now, I have taken band 4, band 2, 3, 4 and 8. Band 2 is taken in blue region, band 3 is taken in green region, band 4 is taken in red region, and band 8 is taken in visible and near infrared region. And all these 4 are having same spatial resolution, which is the 10 meter, right? Whereas other images are having different spatial resolution. That's why I have taken these 4, right? And band 2 is blue, so I have given band 2 as a, which is in our case it is 1, and green is 2 and 3, right? So band 3, which is a red in our combination, has been given in the red channel. Band 2, which is a green, as a green channel we have given. Band 1, because the information which is occurred in the blue wavelength has shown with the blue color. The information which is occurred in the green wavelength has been shown in the green. The information which is occurred in red frequency has been shown with the red color. In this case, we will see the true color combination. So true color combination means if you go to the sky and if you look at this image from the sky, the manner how you see the land is the same. The thing is that when you use the specific combination of this band, some of the features on the Earth's surface or in the future which cannot be seen by us right now can be visible easily, right? For example, so here we have vegetation, right? So we may not identify which is a healthy vegetation or which is scattered vegetation in this case, because we see the green color which is spreaded everywhere wherever the vegetation is. But when you want to classify the healthy vegetation or dense vegetation or scattered vegetation, and this false color combination, or which is called as a standard false color combination, will help us better than what we look at here. In this case, the standard false color combination is we have to put this near infrared in the red channel, and red into the green channel and green into blue channel. So in this case, you will get better idea of vegetation. That's why, like, when they want to read the satellite imagery for vegetation identification, people used to use this combination, right? For example, like here all are similar. Like here, do I have anything? Right. See here, this red. Here we have the different patches with these areas, right? That means the vegetation which is present here is different from here. It can be healthy or it can be dense, or the entire character is different. So this standard false color combination used to identify mainly for vegetation. See here, here also some of the features are very clear, and here you can see some different features are there. And when I change the combination, so you see the different phenomena which was not highlighted in the last combination. Now it is highlighted. Can you see here? It was not highlighted so much in this group of combination, but here you can see these features can be easily identified. It is very clear that it doesn't make that like there is a changes in the pixel. There is no changes in the raster band pixels. Only how it is visualized using the different this color schema will make us to identify some specific features very clearly. Am I clear?
Okay, sir. That means it is not important that we are using false color to hide any information from the outside or terrorist or other things. It
See,
is
for example,
not perfect.
see, for example, now I am doing supervised classification with this imagery, right?
Yes.
So we know that when we do supervised classification, it is necessary for providing the samples, right?
Yes.
So I may use this 432 when INR in the red and red in green and green in blue to make to pick up the samples for vegetation. So when I want to pick up the samples for barren land, in this case, these barren lands are not much visible. See here, there are some areas which is not covered by the vegetation, which can be a barren land. So when I change the combination here, you can see these areas are visible very clearly. And easily now I can pick up the samples from this area saying that these are all barren land.
Sir, that means as I am changing the band combination in different color gun, that is the DN value are not changing.
Not at all changing. You are not at all manipulating with the DN. This is only how you represent your data with the different color schemes.
Okay. That means I can understand which objects is which one. That is, I can
Yes,
separate
yes. To highlight the specific objects very clearly.
Okay, that means the algorithm, it will take the original DN value of the pixel.
Pixel which never ever change when you change the combinations of it.
Sir, and another this similar type of question. If I am using only single band and I know the threshold limit that 0 to 0.5, this is representing water, and this much to this much is vegetation, then if I, on the basis of that information or the knowledge, if I classify, then I think I don't have need the all the bands, 6 bands.
Yes, you are right. You are right. You are right. But the thing is that in real world, it doesn't happen like that. Okay. Because I will show you that.
Okay, because particular in particular one band there is the much more information, only one or two objects like this, no sir?
Yes, if you have like that, like if you know, like you have the pixel value from 0 to 300.
Yes.
In which from 0 to 10 is water body and 10 to 100 is agriculture land and 100 to 150 is build up. Straight away you can classify it into different groups. But the thing is that in real world, the representation of the information is not like how we feel. Like just a minute, I will show you. Do you see the water body here?
Yes, sir.
It's a single water body, right?
Yes.
So, right. See, I will show you the how in real world the pixels are stored, not like from two, like I click on here, but before that I will see like visible layers. Yes. See, in red, the pixel value is 1029. In green, the pixel value is 1381. and or else we will take only the red 1209, right? It's a water body, the same water body. I'm clicking here. What is the value here? 1187. The same water body here, this is 1194. When I click on here, the pixel value is 1172. When I click on here, this is 1170. So even with a single feature or single kind of form on the land surface provides different pixels, right? And one more thing, like this is a combination of 3 bands here we have, right? Do you get me?
Yes, sir. Yes.
So the features, when you get it in the satellite imagery, even for the single pixel, it the value get changes, right? Sometime what would happen, like see here, like this is also water body, right?
Yes.
So this water body has the same reflected value of the vegetation here. See, what is the value here? This is 1284. If I click on this vegetation, some vegetation may come near to the water body pixels, right? So in that case, this classifying from the thumb root using 0 to this is this, 0 to this is not possible directly. So that's why what we do, instead of saying from 0 to 50 is a water body, we select the sample saying that the pixel which is in this limit is the water body. Because we do not know what is the pixel value of water body, so we collect it here, then we say the same pixel values in anywhere in the satellite imageries belongs to water body. The same thing we do here. Am I clear?
Yes, sir. But when I try to extract the sample for supervised classification, if I have a layer stack or band composite, it is 6 band.
Okay.
And I'm alternating the different band to extract different types of information. Suppose 432 for vegetation and 216 for built up, like this. If I change continuously this band combination and extract the pixel value, then it will be hamper the algorithm, any types of
No. The thing is that whatever you do here, see the band combination with any software, right? It does not change anything in your pixel value.
Okay.
Your pixel value never ever get changed. See here what I do here, just I click on here. For your understanding, I will go to the corner, so you don't want to get confused of it. See this corner, what is the pixel value? You that only take the red 1756, right?
Okay.
I will move on to another. So still it is 1756. Then I move on to here. Still it is 1756. The pixel value never get changes if you change the band combination.
Okay, sir. Thank you. Because it was little confusion to me.
No.
Because when I'm extracting different information in different combination, it is visualized very well.
No. Just a minute. If you are having more doubt on it, like I think like here we have. This is a single band. I have not layer stacked it or composite. So this is the band 2, right?
Okay, sir.
This is the band 2, which is taken in band 2 in blue, right? Band 2 is blue. So here I give the symbology of blue color here, right? Then band 3, blue, green, and band 4 is red. Right, what I do, I transparent it. See here also you will get the same kind of similar this composite image. See, these are all individual bands for which I have applied the color pattern of in which region it was taken. See, this is the individual bands, right?
Okay.
So when you combine this blue, green and red with its color, you will get the similar kind of what we get in the composite. So we do not alter pixel in any manner in it. Only the color scheme what we give here is provided to the pixel values.
Displaying. Okay, sir.
Okay.
Okay, sir. Thank you, sir.
Okay, thank you. Is there any other question, Sardar sir?
Sir, questions are in chat box only.
What they said, how can I clip out area depending on specific attributes from an unsupervised class image? How can I clip out areas depending on specific attributes from unsupervised classified image? So Swati Bangel, can you unmute and ask your question? Like you have the polygon.
Swati Panale, please ask your question. You may ask in Hindi, in Marathi. I will translate to sir.
Yes, good evening, all of you. I have just one question. You have shown us supervised classification.
Hmm.
In that, we have to train some sample, right? But
Shilpa,
how can I clip out areas
Bubba,
depending on specific
Aditi
attributes?
Halli.
Okay, from an unsupervised classified image. Yeah, I go through the supervised classification, but in that some cases we have to do unsupervised classification also, because in some dense forest areas or some another areas where we cannot reach out,
Yes, yes.
in that case we can do unsupervised classification also.
Okay.
But how can I clip out areas on a specific attribute
Okay, okay. So
for
the
an unsupervised classified image?
so the result of whether it is supervised or unsupervised or object-based classification will be stored in the raster file format, which you may save in the TIFF file format or IMG file format or JPG file format. So the nature of file will be same whether it is supervised, unsupervised, or object-based. So when it comes to the clip, all these three will be same. The result of all these three. So like. When we want to create a part of a larger image, so I have an image here, right? We have the classified image. I have the classified image. Whether it is a supervised or unsupervised or object based, everything will be saved. All the result will be saved in the raster file format. Then our result will be look like everything same, right? There is no much different in the file format. So when you want to clip it, like for your what I do, I create a save file. For your understanding, I want to create a vector data, or else I take here larger data. I take these. So we consider this is your study area, right? And
Okay.
do you have only one polygon or more than one polygon?
Only one polygon.
Okay, this is like we will consider, like even if you want to go like we will consider this is our study area, right? So kind of some streams are there along the river, you want to do that. So any existing GIS or remote sensing software have this tool in it. Here I can show you how it works in ARC Pro. It's the same in ArcGIS desktop, right? We have the tool here. It is called as clip, raster clip. So the data what we have is a TIFF file format. We have the raster clip. It works in the same in ArcGIS desktop. and we have the tool in Iradas also, NV, any software you name it. Here clip raster, our input data is our result, this classified ML, and output extend is this, which is a classify one, this one. Then I say use input feature for clipping geometry means, so this geometry will be considered for clipping.
Okay. Okay.
So here we have our result. The area which falls within the geometry of the polygon is clipped.
Yes.
Alright. So this tool is available in all the existing GAs and remote sensing softwares. And you have lots of
Thank you.
material.
Thank you, sir.
Okay, okay. Then, okay. My system takes too much time to process the result. What is the best system requirement? Faster processors. So the one of the major hurdle what we face is the system configuration, because the software what we have today will not be same in after few months, because they are keep on updating all the things in it. So now the software, at least the software what I'm using right now, requires a RAM capacity of 16 GB. So which may cost more than lakh rupees in Indian money when you want to buy the laptop with the configuration. So I cannot tell you the which is the best one, and I can tell you one thing: um, the suitable one for the right time is which is the high end uh, system which is available in the market. Even the high end what you buy today will not be enough for the softwares in the future, so we have to update continuously. So if you want to buy right now, you just go for the high end configuration, which is having 16 GB of RAM and like at least 500 GB of SSD hard disk and 4 GB of graphic card. Okay, whether the color of the car responsible for reflect of FCC. No, FCC is a combination of different wavelengths which has shown in the specific color, right? So even if you see this color in the single band, it will be shown in the gray color, because the gray color is the automatic or default color which is coded by which is default coded in the softwares. Like if I want to export, like, or else I do one thing, in all the three channel I will put only one band, so we can see only first band, first band, first band. Right. See, now I look at only band 1. The other two bands I have hide here. So in this, if you see the red color, now it looks like a gray color. So if I put the other colors here, like how I have done here, like see. If I add any other colors here, then that color will be applicable on the screen. So see, here we have the pixel value, and different pixel values are represented with the gray, or the higher the value with the right and the lesser the value with dark black. Anything else you want to ask me? Sardar? Yes. I have not used it, but here, see, what they have mentioned here. So when we change the bathymetric, when we change the band combination, some of the features on the satellite imagery will be visible clearly. So here what they say, when you make the arrangement of the pixel as the band 4 in the red channel and band 3 in the green and band 1 in the blue channel, and these bathymetry informations are visible, clearly visible, they have mentioned. Yeah. Band 1, 2, 3, 4 are having same resolution, like here we can see. Not here. Sorry, band 2, band 3, band 4. This band 2, 3, 4 is having same resolution, and 8. So no problem. Like now, what they have done, like they have made all the bands in the same resolution of 16 meters. That is available. I can show you that. So when you download the Sentinel data, so they have given the folder R10 meter, R10 20 meter, R10 60 meter. So here all these bands are classified into 60 meters that you can download. See, I am opening this band 1, and if I see the spatial resolution of it, it's 60 meter, and the band which was 10 meter, now which is a band 2. This is also 60 meter. So you can use these bands combination to know the bathymetry. But it's only for visualization purpose. By seeing it, you can digitize this bathymetry information, or you can extract it using digital image processing.
Thank you, sir.
Anything else?
I think there are no further
Sir?
questions in chat box. Yeah, someone is asking.
Nothing. Thank you, they have said.
Okay, okay.
Okay, thank you, Sardar. Then we will meet
Sir,
in the next.
just give me to express formal vote of thanks. You denied for introduction, and your talk itself is your introduction. Uh, I request my colleague Mohite Madam, please extend the vote of thanks. Mohite Madam, are you
Yes,
online?
sir.
Yeah, please, please.
Yes, sir. Yes, sir. Good evening, everyone, to one and all presents here. I incredibly honored to have been allowed to extend the vote of thanks on the 14th day of the Digital Image Processing Workshop on the behalf of Department of Geography, SP College Devru. A special thanks to today's resource person, Mahalingam sir, for accepting our invitation and take out time from your busy schedule to organize the workshop. Thank you, sir, for your valuable guidance. I also thanks to our Vice Principal and Head of the Department of Geography, Dr. Sardar Patil sir, to organizing such a great platform to all of you. And finally, I would like to thank you all the participants who have made this workshop possible. Once again, thank you all for your presence. Thank you, sir.